Hi, this is Corey Kinnick and welcome to the longer version of my final project presentation. My project title is Detect Topics of Tweets on the Fly using Kafka Streaming API. So let's dive deeper into this project. In a nutshell, the summary of this project is I'm using a data source of 1.6 million tweets from Kaggle. So that's a frozen batch set of tweets in bulk, and my input of the pipeline is raw tweet texts, and the output is labeling each of these tweets based on their underlying topic. And what a topic is LDA is a clustering technique, unsupervised learning method that clusters texts into topics, underlying topics. And for this, I will be using Spark and applying this model on a Kafka streaming data. My runtime environment is a Google Colab notebook, including both of these services. And the pipeline I built has two parts. In part number one, I will be using the entire corpus of the tweet texts to build an LDA model, and then deploy that model as a black box model on streaming data in Kafka. So what is LDA? In part number one, I will be building this unsupervised learning method. So basically, its purpose is to discover abstract topics, underlying topics in the text. We are not looking for certain keywords or filtering based on certain patterns. It's not n-gram. This is basically kind of a dimension reduction technique like PCA, if you will. So based on these reduced dimensions, the algorithm is categorizing the text based on weights of each topic, and whichever topic has the highest weight, we will throw that text into that bin. Some will be falling into that topic sharply, and some of them will not. So my pipeline is very straightforward. Building the LDA model pipeline. First, I take the tweets, I clean them and tokenize, stop words removal, and eventually vectorize the text into numeric. And to do that, I use TF-IDF approach. And then finally, we train the model using LDA. So Spark library has all these classes readily available. So the final product is a feature vector here. In the end of this pipeline, I have a built, trained LDA model ready to be deployed. And that's a snapshot of what kind of keywords most come to the front when I look at my topics. They do not, basically, the algorithm is not looking for specific keywords again, but these are the words that has the highest weights in those topics. It just gives you an idea what kind of topics we are talking about here. And the final result is something like this. You give the input text and the entire pipeline runs, and the output is basically a label for that text. So in part number two, I deploy that model on streaming data. For streaming data, I have a producer here. It is continuously running. It is feeding the raw tweets into a Kafka topic here. And from that Kafka topic, I have a consumer app here. And this is where the black box LDA model is used to label those texts. So it follows the pipeline that I described just earlier. And eventually, it routes these texts based on their topics. So I gave 4 topics as my input, and created 4 different Kafka topics for each of them. So eventually, this whole pipeline is a kind of on-the-fly labeling of the text based on their content. And the final product will be something like this, and you will realize that they will be just streaming data. This is moving actually. So I will add my references on the description, but you can see them now. So let's go to the code and look at some highlights. To start with, realize that this is a Google Colab notebook and everything is running on single notebook. So piece by piece, I will go to the, I will break down the pipeline here, and the format of this notebook follows the PowerPoint. So first of all, I configure my environment. This is quite straightforward. I install Kafka, I install Spark, latest Spark version, and we have Spark job running here, and I import all the libraries. As you can see, I don't even import any pandas or scikit-learn here. There is no place for them in this project. And here, first, part number one is building an LDA topic model. So we read the bulk data. So everything is coming from that Kaggle file, around 250 megabytes. And we have no problem taking it to the memory. So this Google Colab that you are seeing is a 2-core VM that has a GPU in Google servers. So everything I install here is basically like a Docker container, idempotent. You can create it and destroy it. It is a clean VM that I can create multiple times and access remotely, obviously, like a Amazon Web Services EC2, if you will. So the first pipeline is straightforward. There's tokenizing, stop word removal. I added ngram, but I ended up not using it. Anyways, I have this words cleaned, and the next part I do vectorization. I turn clean words into vector forms. So far so good. This is basically the beginning of any language processing pipeline. In the next part, I built a model train. This part took a lot of time. Long story short, this is the critical point. The LDA is what we have for what I used from the machine learning library here. If you look at the documentation, TF-IDF class of Spark is what I used, and count vectorizer is what I used. And we have LDA. Quickly we can find. Well, LDA should be under clustering. Here we go. As you can see, this is basically the it gives the minimal idea of how the LDA model can be fit. It's quite straightforward. And sorry, going back to my notebook. So here is just a detour, a visualization to give you an idea what kind of topics we are dealing with here. And going forward, we eventually, each tweet can be represented with their topic weights. As you see here, we have a an array of length 4 for each text. We are able to convert it. And what I do is using argmax to find the highest weight, and let's throw that one into the winner into that bin for the topic. So that's why I called it winner topic. So that was part number one, and so far we built an LDA model. So part number two is where the fun begins. So we have a Kafka producer to provide the streaming for tweets. So first of all, let me mention this here. So before we start anything, we need to create Kafka topics. And here what you can see is I create my topics, and I have one topic for receiving the raw texts, which is tweets. And topic 013, these are the 4 topics I will send. So producer, so this is labeled 1, and the layer 2 is here. And this is a mini app that I use to continuously feed the tweets. As you see, I have a sleep command here that will basically slowly digest this bulk source of tweet, pool of tweets, slowly in many hours into the Kafka topic. So the trick here is this magic command. So when I run this cell, it will not run it. It will simply export it as a separate PI file. So once I do it, in the next cell, I can do no hop. As you can see, this is the Linux terminal command. It will run this Python file and record the output to a separate out file. So what this trick allows me to do is when I run this cell, it will basically push this mini app into the background, and I will continue running my notebook. I can carry on. So when I push the button, I start feeding the Kafka, the tweets into my Kafka topic, and carry on and focus on the deployment part. So that is running now in the background. I know that. I can see that. And I will go ahead and basically check the number of topics the tweets I have in that topic. So after 10 seconds, I accumulated around 50 topics in 2 partitions, more than 100 total. So that's very good. Everything is running, so we can go ahead. So part number 2, this is where the most important part of that project, in my opinion. So there is a function here, as you see. This function takes raw tweet texts as a string and spits out integers. So basically the job of this part is the function is to basically label any text based on their topic. So what it does, as you see, first converts the raw text into one row Spark data frame and deploys the entire pipeline, which is already trained. So it's super cheap operation. And these models are coming from the cells that when I trained in the first part of the project, and they are recorded in the runtime environment of Python, right? So basically what I do is a very inexpensive operation to give the text and deploy the model and predict the topic of that text. And these models are already trained above. The expensive part of training the model is done in the previous part of this notebook. So going forward, this is where the second part of the operation is running. So what I mean is, in the presentation, it refers to deploying this black box function here. So this part is in the notebook, this part. So let's look at it. We have a Kafka consumer and we have a Kafka producer. And the pipeline, I had to separately write it here again. So we have the Kafka consumer. The consumer is consuming from tweets. So what it is the tweets are coming to this Kafka topic. It is consuming from this topic and sending, basically running the function, this function on the tweet text. And this will give us an integer, basically. I can add that. So if there's a text in the tweet, obviously it will give us which topic it belongs to. It has the highest weight tendency for. So as you can see, some tweets has no text. So many of the tweets, it categorizes either topic 1 or 2 or 3, and what it does is to send to the different topic, and this is the topic name, topic 0, 1, 2, 3, 4. So whatever topic it was categorized as, it will basically send it to that topic. So as you can see, this is running in the streaming way. So 1.6 million tweets will finish in a few hours. When it does, this code block will stop running. And finally, in the very end of the end of the notebook, I can count how many topics were sent to different topics. This one is obvious, 1.6 million, but these ones will be basically the sum of these 4 will be equal to the source, basically this left to right. So what you see here is currently moving. This streaming application is those tweets are flowing from the source master data. They are being provided into this black box, and this black box is just sending them to different topics, and soon after this will basically finish. Thank you very much for listening, and these are my references.